Hello everyone, today I'm going to start a topic called Symbolic Live UEFI Debugging. My name is Ethan Zhu. Today I'm going to give a general introduction, and later on I'm going to talk in different aspects of the way I'm doing with the UEFI live debugging. So what we need is a Yourland codebook, an NTP, NanoCode probe, and also one debugger, NanoCode debugger. How it looks like? It looks like this. So this is the setup of the debugging environment I'm using. Left side is a notebook called Yourland Codebook, which is specially designed for programmer, for which laptop you can freely experience all programming from UEFI, U-boot, kernel, grub, all free software you can experience to install and test with yourself. And there's also community with this notebook. So at any time with these aspects, if you come into problems, well, we have a chat group and you can ask the engineers or other users to share it with us, so which is very convenient. This book is specially designed for programmer. So in the middle, the orange one is called NanoCode probe. It's a small device like a J-Link and all, etc. used for JTAG debugging. There's only 5 pin has been used now. What's special with this? It's actually this debugging for the notebook reuse the SD card slot. So the slot, the original function is used for SD card, but in the UEFI or Linux kernel, in the underneath driver, we can set the pins to change the function of the relative pins to enable for JTAG debugging and also for serial port function. Let's go in details of the NanoCode probe. So we can see the signal pins. There's the signals for SWD debugging. There's also pin 7 and 9 is for serial port. So the connection is super simple. It's very neat, very convenient. Just say USB port connect to the machine, to the computer running the debugger, NanoCode debugger, and then the target machine, the notebook. Then we can do all kinds of debugging, UEFI debugging, U-boot debugging, Linux kernel debugging, the application debugging. It's all capable. So if you want to know more about NanoCode or Yourland codebook, you can go to the website nanocode.cn. You can find all informations or wiki or guideline regarding all topics. So this is the NanoCode debugger. Because the loading of debugging takes a little bit time, so I have pre-connected the debugger already. The left side, the green button left side is showing called kernel debugging. So now we are at kernel debugging mode, and this is the log. I start a new session, Nano Debugger version, starting KD sessions. Type in USB using OCD, OpenOCD. The target name is called LYL, is Yourland. These are all connection informations. Then the symbol loaded, the symbol path is over here. And you can see there are 8 cores over here. So NanoCode Debugger can load all debug symbols. So this is the debug symbol loading sequences for all modules. It's almost more than 100 symbol files have been loaded. So now the target machine is still running. We can switch to mobile extern to have a view in live mode. So the name is called Yourland. The CPU is Rockchip RK3588. Now it's running at 0.81 GHz. There is 16 GB memory. The UEFI I'm using now is compiled and built June 17th. Now I can go to the next level of menu. I can go to UEFI shell. Let's go back to NanoCode Debugger. So now we can pause the machine. Yep. The machine has been reached the breakpoint. We are at address over here. The assembly instruction is read. We are now at common exception handler offset 060C. Oh, one more thing, I have to load one small script which I have prepared earlier to load Astro modules and also set up symbols and etc. So more modules have been loaded. The script automatically executes a K command. This is used for backtrace. The NanoCode Debugger commands are mostly compatible with the WinDBG debugger, the most powerful debugger used for operating system development. It's really powerful, and especially the debugging abilities. So NanoCode debuggers use similar debugging engine, and then the commands are compatible. So at the top of the call stack, we are now at exception handler. So the call stack looks not complete. So for this, we can do one command, T, single step, return to its caller function. Wait a moment. So now we are back to call dispatch event notifies. So this is an event loop or event handling of UEFI. And then we know we can do a K command again. Then we can see the full call stacks since the first entry, dash entry. This is from the module ARM platform pre-pi unicall. And then to DXE call, then to BDS DXE, UI app module, setup browser, UI, and shell. So this is a complete call stack with a real machine, not with emulator. So now I can do U dot means current PC to do disassembly. There's a BL instruction over here, means to call another function. So let's copy the address. We can use the command ln list nearest address. ln. Yes, it's called call acquire event log. Yep, this is the exact place where we are. So I'm going to add it to the right side, the script, the commands I had done. And later on, everyone can repeat these commands to practice. It will be easier for everyone. Then we can do LM again to list all modules. So from here, we can see some modules debug symbol have been loaded already. There are most of the modules debug symbol haven't been loaded yet. So the next command I'm going to explain a little bit is called X examination. X command. So we can X DXE CORE, the DXE module, to look up all the debug symbols the module has. It's a long list. But by this way, you can see all the debug symbols. Of course, I can break it this moment if you don't want to see all. Of course, I can also check only the global variables, starting with G. I find this is really useful for most of the time if I can check the global variables and its data structure or its real content live in the memory. Another kind of a variable start with M, also very useful. So next thing I can examine the exact symbol. G image handle. Yeah. Left side is its memory address. This is an image handle. I can apply with a DA, dump ASCII, to see whether there's a string exists at this address. Yes. Start with the HNDL. This is the signature of I handle. Of course, I can do DB2 to show the bytes. And then I can see a range of a memory, how it looks like. The next command called DT is the most time I'm using with this powerful command called display type. I'm almost using it all the time. So next instruction I'm going to show is to inspect the system table. There are two commands separated with a semicolon. The left side is to display the signature of system table. POI is to get a pointer at the memory address. And then it's the display type. -R2 means recursively expand the data structure to 2 levels. And this is the type called UEFI system table. And then the memory address is an address contained in a GST. So let's have a look. IBISYSTF. This is really amazing. Now we can see a whole system table, real time, how it looks like or how it is contained in the memory, the whole structures. There's console out and also the interface functions. There's protocols. The system table is a very, very important data structure of UEFI. Later on, I'm going to dive in more details. The next one, we can dump a special protocol. Protocol is a very important data structure or very important concept with the UEFI programming too. So this is instruction to dump UEFI shell protocol pointed by a global variable. Yes, exactly, it is. So now we can see the whole protocol of shell. I find this very useful because when I get the real symbol or address of this protocol, I can easily set breakpointers on the one function or interface which I'm interested to break it, to do inspection, to check memory, to check variables, and to read the source line. Next one, I'm going to show a real powerful DT command to dump all handles in the system. Okay, so let's start with the DT I handle. It's a global variable G image handle. Yes. Again, so we can check its signature. Yes, handle. Then we can expand one more level with -r1 parameter. So then you see the forward link and also back link. The list entry chain all handles together. So this field or member is called all handles. The next command is to dump all handles out of the systems in real time. How it is written is dt-r1 to exam I handle at the address of G image handle, and then -l is the list entry, and then we're going to check it forward. So use a forward link, and then -y is to inspect locate request member and also key. So this field and also the next field key. Let's have a look. Yes. Now the NanoCode debugger is dumping all handles exist in the UEFI system. So if we want, later on we can inspect every handle in details. So after this is finished, I'm going to show how we can do breakpoints. So when we can browse the code to pick up the location which we are interested, and we can set a breakpoint over there. Very convenient. When the breakpoint is hit, and then we will stop there and to start our inspection of the information which we are interested in. So you see now the shell is frozen. It is stopped by the debugger. Okay, now it is finished. So we can set a breakpoint just by click the left side of the source code file. Yes, now the breakpoint has been set. And then the command is go. We can let the machine run in the game to see whether the breakpoint will be hit and stopped. Yes, looks like the breakpoint has been hit. So we can inspect the current location with the disassembly U. We can step 2 more steps to see the BLRX2, the calling, to see where exactly the function, the notify function we are calling. So T 1 time, and then T 1 more time. Yes, let's do ln x2. We're going to call the call check timers this time, the notify functions. So I can do 1 more T to step in call check timers function. Yes, it takes a little time. Now we arrive at the function call check timers. And then we can do dv to check local variables. This is a check event. A check event variable. So now we can do dt I event at the address. Yes. Now the event has been shown. Of course, we can do it recursively too. Okay, we want only one level. So again, we can traverse all events, notify link to see whether we are able to do it. -L notify link dot forward link to inspect all notify functions. Okay, let's have a look. This is not successful. So this time, let's apply for signal link. Yes. From here we can see all the signal links of all the events is going to be signals in the system. This is really powerful, all in real time. So by doing this, actually we don't need a lot of printf anymore. We can just pick up the location which we are interested and set breakpoints over there. And to stop, dump the code trace, check or inspect the variables or memory, the program logic. Wow, there are so many events to be signaled. Next step, let's try to set a breakpoint on one of the notify function. Let's hit finish. Okay, it's done. So many signals. Let's see. We're going to pick up one notify function. Will be mostly called regularly. Okay, let's set up the breakpoint over here. MNCDXE check cards callback. BL. Let's clear the first breakpoint. BL again. Okay, let's go. To see whether the breakpoint will be hit. Yes. In a very short moment. That means the event has been signaled again and again. Wow, it's here. Let's apply a DV. Yes, the event is over there. DT I event. Yes, this is the event has been signaled. And then let's check the call stack. Beautiful. A full call stack. We can switch between frames with the .frame command. Let's check number 1. It takes a little bit of time. Yes, it's here. Line 191. Can we switch to first entry? Let's give it a try. 1, 2, 5, 6, 7, 8, 9, A, B, C, D, E, F. code stack is so deep. Wow. Now we go to the early beginning. B never return. Isn't it powerful? Last thing, I'm going to do a DQS SP. This is also very interesting. To dump the symbols located in a stack. Yes. So this is the general introduction today. So for me, NanoCode Debugger is really powerful. You can do kernel debugging, UEFI debugging, U-boot debugging, and you can play with the notebook yourself and then to check every corners. There will be no secrets anymore with NanoCode Debugger. And you got free software really in a way called Freeland. Because you can inspect every byte, every bit, and to inspect whole logics running inside the machine. So thank you for watching. This is the general introduction today. Later on, I'm going to post more episodes every time with one small topic. See you later.